Hello, and welcome back to the Precision Medicine Pulse, your weekly news update about the precision medicine industry. Today's date is February 18th, 2025, and we've had some pretty cool stories that came out over the last week, and I'll go through them. Some good news, some bad news. First of all, what we'll be discussing today is a really promising multi-omics slash data science paper that came out about heart failure targets. They identified 58 potential heart failure targets, which is really exciting news, and we'll go into why in a little bit. We'll also be talking about e-skins, electronic skins. Pretty cool. In fact, the only thing more cool than e-skins are self-healing e-skins, and we've got an exciting thing to talk about there also that came out during the week. We'll be looking at Roche's new SBX platform. It's their next generation sequencing toolkit system, and that's got some potential, and we'll be talking about why. And then, on a lighter note, on a less exciting note, we've got some bad news coming out of Bio-Rad Laboratories. Like we had some sad news coming out of Illumina last week, where they got sanctioned by China. This week, Bio-Rad had their bad news. We'll get the bad news out of the way first. They announced that they had $1.8 billion loss last year, and they had to contract or make their expectations and their forecasts for this year smaller too, which is going to hurt. It's going to hurt if you're an investor in Bio-Rad, but more importantly, if you're an employee. They announced that they're going to have to reduce their workforce by 5%, which means for a company their size, that's 350 people are going to unfortunately be let go. Now, Bio-Rad, they build out and they offer essential tools and solutions for researchers and clinicians in the cell biology, gene expression, disease detection space. So, if you're listening, I hope and you're a Bio-Rad employee, I hope you're not affected. But if you are affected, this is tough. It sucks. It feels like every week we're kind of getting some bad news in this industry at the moment. The market is definitely in a headwind towards the industry, but if you were affected and you work for Bio-Rad, I'm sure there'll be other places looking to snap you up. The company does some pretty cool work. I'm sure whether you're you're a lab technician, you're a data scientist, process engineer, PM, whatever you do, I'm sure there's going to be a big demand for your work around the place, and hopefully you get a job soon. That's the update on Bio-Rad, and up next then will be some better news, some actually quite really exciting news coming out of Mass General Brigham. I came across a paper this week. It actually came out 2 weeks ago, so some of you might have already seen this. The paper was published in Nature Cardiovascular Research, and it was around new potential drug targets found for heart failure. Specifically, Dr. Danielle Rosselli and all of her co-authors, there's a plethora of them, they combined proteomics with transcriptomics and genomics. So they took a complete multi-omics approach, and they got data on the proteins, on the RNA, and on the DNA, and they looked at this data, and they looked at heart failure, and they were able to come up with 58 new potential targets for treatments to heart failure, which is really exciting. In their research, I think they come up with 70 targets overall, but 12 of those targets had been seen before. So it recreates some existing research, which you'd like to see, but then with the same methodology, they were able to come up with a bunch of new drug targets. And that's really exciting, because heart failure, I think it causes 14% of death in the US every year. Millions and millions of people. And we've got 58 new targets, right? So likely a lot of these targets will kind of run into dead ends, or maybe they're going to be real edge cases if they do, if we can get some clinical trials to show effects. But in any case, if you can make any dent on that 14%, you're saving millions of lives every year. So like, we'll see in a few years, but if these new targets lead to, we'll see in the next decade, but if these new targets lead to making any bit of a dent into that 14%, you're looking at this research almost directly saving millions of lives. So that's some pretty cool news, and I missed it last week. I was sickened, so I had to bring it into the update this week. There was another interesting bit of news this week too. Pretty impactful if you live in the world of material science and you're looking at how material science could potentially apply to the precision medicine industry. But researchers out of the Terasaki Institute of Biomedical Innovation, along with a few other laboratories, they made a breakthrough in the field of e-skins, and specifically their breakthrough was on self-healing e-skins. Now, e-skins can be used in precision medicine for like continuous monitoring, or at least theoretically they can be used for continuous monitoring in the precision medicine industry. They're a little bit of the ways off from being used out in production in clinical settings, and there's a few reasons why. One of the reasons for that is, if you have an arm and you get a cut on your arm, you get a scratch, or you bang it up against something, your natural skin will self-heal, right? And so the nerve endings, they'll continue to function afterwards, and it might take a little bit of time, but they will repair. Now, if you have an e-skin, which could be on your arm on the form of a sticker on one of your muscles, or on your heart, like on your chest or on your calves or wherever, they can even put them on prosthetic limbs and stuff like that, or on robots. It's not going to be very useful as the second it bumps up against something or gets a scratch, and it gets a slight tear and it's not usable again. These types of materials, if we're going to be using them and they're going to be experiencing normal wear and tear, they need to be able to function after enduring regular day-to-day wear and tear. And because these skins are really thin, it's tough to create materials that have the properties that they will, be able to either sustain or heal themselves after coming in contact with a tear or a scratch and stuff like that. But the Terasaki Institute of Biomedical Innovation, they came up with a new way of designing and building e-skins, such that I think it was after 10 seconds after the e-skin getting a tear, it would return 80% of functionality in its ability to do continuous monitoring. And I think it would eventually, after a few minutes, it would return up to 95% functionality, which is no previous device kind of would return to 80% functionality after a few minutes. And they've made a great breakthrough here. So we can see these types of devices in the future. Again, we're a little bit of ways away yet, being embedded on prosthetic limbs, perhaps in robotics, but then also on continuous monitoring devices, where they'd be much more lightweight, much less cumbersome than wearing smart watches and the likes. So that was a really exciting development to come out of California. And the final news story of this week came from a blog post that I read by James Hatfield, and it was about Roche's new SBX platform. If you're anyway interested in NGS and keeping on top of the NGS industry and learning about what happens or how to do next gen sequencing from a variety of different perspectives, I'd strongly recommend subscribing to James Hatfield's blog. It's really, really useful, like really useful. And this week he came out with a new post talking about Roche's SBX platform, their upcoming sequencing platform. SBX stands for sequencing by expansion, and I'll go into that in a little bit of detail, how the technology works. But if you think about this from the industry perspective, they're signaling that this is going to be faster, cheaper, and more accurate than other competing ways of doing genetic sequencing. This SBX kind of came out of Stratus Genomics, which was acquired by Roche in 2020. If you know anything about Roche, they're in the, let's say, genomics and sequencing industry, and they're pretty famous for acquisitions. So Stratus was acquired in 2020. Every year or two, Roche are acquiring a pretty cool tech company and optimizing them, as they would say. This SBX platform, it works as follows. So we've got genetic sequences, and what they do is they convert them into expandimers, which are larger molecules, and then they pass these expandimers through nanopore for sequencing. And this is let's say no other company does it exactly like this except for Stratus, obviously. And if it does come about that this is a better platform than, you know, the likes of Illumina's technology or whatever, perhaps this is part of the reason why Illumina's stock has been struggling over the last few weeks and months, honestly. So interesting news coming out of Roche there. And again, I would really recommend James Hadfield's blog. So you should be subscribed to that. You should be tuning into that if you want to stay up to date on NGS. And if you want to stay up to date on the precision medicine industry as a whole, I recommend you clicking subscribe to the Precision Medicine Pulse. We'll be back again next week with more news. And I've been your host, Gary O'Keefe. Have a great week.